Okay, well, we should be recording now. I have several things to go over. First one is a little video on the Turing test. We've discussed um, artificial intelligences, so let's discuss see this little video on the Turing test.
A computer has reportedly passed the Turing test for the first time in the history of the world and has become officially as intelligent as a human. For those who don't know, the Turing test was set up back in 1950 by computer scientist Alan Turing to determine whether or not a computer was artificially intelligent by having a panel of judges communicate with the computer through a keyboard. And if more than 30% of the judges were fooled that they were communicating with an actual person instead of an artificially intelligent computer, the device was said to be artificially intelligent. And allegedly, for the first time, a computer has passed the test in anticipation that has been expected to occur by many computer scientists and a horrific nightmare feared by many.
Okay. We'll now take another look at some additional work here. First place on that Turing test, what it did was it simulated being a 13-year-old Ukrainian boy. Well, as a result, some of the questions were written off as simply misunderstandings with the teenager. And the test was slightly biased because of that. And there have been quite a few later discussions indicating that the test results were invalid. So there you go. Okay, so now let's take a look at at some other issues here. Just a moment. Here we go. The first one. Back to here. Golly, 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 golly. Oh. Screen share. Let's pick this one. Okay, so here's the issue. In order to use good artificial intelligence, good computer-generated intelligence, that sort of thing, usually people use parallel processing, advanced parallel processing. Now that parallel processing can consist of either a very, very expensive, developed supercomputer or parallel processing using network linked non-supercomputers. There's a lot more of that going on. And so what you'll see, you can go look for, they call this either minis, right? And some of these are built in using Linux. So you can use Linux and go get a bunch of old computers and build them up and end up with a computer that processes significantly, I'm going to use the word again, significantly faster than a single processor because it splits the processing itself, makes everything run much, much faster. Okay, so on to that. That's a little bit about supercomputing. You can actually build supercomputer if you wanted to go out and find several old computers and go look on the internet for how to put them into parallel processing. Have some fun with that. Oh, here's some more on parallel computing. So what then is parallel computing? So what it is when you take a problem or an issue and every computer has a series of instructions. It starts with A, it goes to B, goes to C. So what do? This is the sequential processor, but guess what? Sequential, 1, 2, 3, okay, but now we want it parallel. Instead of following one sequence of instructions like this, it breaks that, rotates it down, and now the problem can be broken into several sets of instructions executed simultaneously. So guess what? Instead of one serial stream, 4 serial streams executes somewhere between 3 and 4 times as fast as a single processor. Think about that. 3 or 4 times as fast as a single processor. That is why, if you look at some of your new laptops and some of the laptops over the last 5 or 10 years, they'll have dual processing capability. Ta-da, they run faster, even though the clock speed seems to be slower than some of the other ones, huh? Isn't that interesting? Okay, so that's the way it works. That's a little bit on serial processing. And now, I'm going to come back to Watson because it is very exciting. So we've talked a little bit, or we'll talk a little about recycling old electronics. So how do you do that? I just throw them out. No. You can turn gadgets in to some retailers. In some places, the distributors themselves, such as Apple, will take old computers or old handhelds or old phones, things like that. In other places, there will be public programs where, for example, we have 3 or 4 or 5 old cell phones here in the desk. We could take those old cell phones down and give them to a store, and that store will recycle those cell phones and then either give them to people that have no phone at all. And there was one program a couple years ago where the organization distributed free cell phones to servicemen that did not have them, that were out of the country, so that they were able to contact their families. So there are different ways of recycling old electronic devices. And here they talk about Dell, Lenovo, Toshiba, and Apple. Okay? So that's some of the ways to recycle. And these people have responsible recycling, not the recycling that simply loads everything up on a boat, ships it over to somewhere in Africa, and people burn it and stir through the ashes. Not that kind of recycling. Okay? All right. Now the exciting one. As you know, I've talked to several people in the discussions this last week or two about some people that I'm working with that sell insurance. Well, they are using a thing called Watson to help sell their insurance. So that is an IBM product. Watson, it's an advisor. I want you to watch this little video about Watson. So here we go. About a 1-minute long video.
When IBM Watson beat the best Jeopardy champions in the world, that was just the beginning. One great example is IBM helping organizations to use Watson to interact with their customers.
Last year, there were over 261 billion calls made on call centers, and 1 out of 2 calls went unresolved.
A new generation of consumers has a far greater set of expectations of what they want from their companies and brands they interact with. Watson's transformative technology has the ability to completely change how this interaction takes place.
To be able to answer questions and to engage the customer in a dialogue that establishes trust. That's what we're really trying to enable here, forming that relationship with the customer.
Watson is coming in at the right time as a technology to help improve client engagement, both in a self-service as well as an agent-assisted model.
Okay, I want you to think about what they just said. Customer service and customer trust. Who is the customer engaging? They're engaging a supercomputer-driven artificial intelligence named Watson, which can be adapted for different industry uses. What did they just say? That computer is engaging customers, and the customers trust, T-R-U-S-T, trust that computer as an engaging person. Wow. How does that fit in with that Turing test? think about that. Enjoy your week. If you have any questions, make sure send them out. Give me a call. Take care. Bye-bye.